So in this session, we will see time lags for breakdown. We have discussed Townsend theory of ionization, primary, secondary ionization. We have derived Townsend's breakdown criterion. We have solved problem and then breakdown criterion, Townsend's limitations also we discussed in last session. You can see previous videos uploaded on the channel if you have missed any session. So in today's session, we will just discuss why time lag is there for breakdown. It means that suppose if you will apply voltage in the any insulating material between the two electrodes, if you will apply voltage, then why breakdown will not occur immediately. Now here, please don't confuse between the lab process. In the in the laboratory, we just go on increasing the voltage slowly because objective is to find out the breakdown voltage. So we are increasing voltage slowly and then we find out at what voltage breakdown occurs. But suppose now I am keeping gap between the two electrode 1 centimeter and breakdown voltage of that gap is suppose 30 kilovolt. If I will apply 30 kilovolt directly, then also breakdown will not occur immediately. So breakdown will occur after some time even if voltage is sufficient to cause the breakdown. That is called as time lag. Now what are the different time lags? Why they occur? On which factor they depend? We have to discuss in this session. So let us start. So I have just explained you the meaning of time lag. So there is a time lag between the applications of a voltage sufficient to cause the breakdown and occurrence of breakdown itself. Just now I have explained. Suppose if we'll take a electrode and suppose this is cathode and this is anode and I have applied direct suppose DC voltage. Okay. I have applied direct DC voltage. Suppose gap is 1 centimeter and breakdown voltage of this gap is 30 kilovolt and I have applied 30 kilovolt. Means this 30 kilovolt is sufficient to cause the breakdown because it is the breakdown value. But even if I will apply the 30 kilovolt, we will see breakdown will not occur here immediately. So that is called as time lag. So try to understand definition. So there is a time lag between the application of voltage sufficient. So this is the time which I applied. Suppose I just applied at 10:20. Now 10:20 morning time is there. I have applied 10:20 30 kilo and I will not get at 10:20. Even I am not at 10:21 also. Okay. So voltage sufficient to cause breakdown and the occurrence of breakdown itself. So I will see I have applied 30 kilovolt at 10:20 morning, but I could see breakdown at suppose 10:22. Suppose to understand I am telling, but it will be just in second. So to understand I am just saying 10:22 morning. So 2 minute will be time lag. So the lapse of time is known as statistical time lag. Okay, so lapse of time is known as statistical time lag. There are different types of time lags types of there. So first is statistical time lag, then time of formation, and then total time. So the appearance of electron is usually statistically distributed. So see, we have discussed ionization theory using Townsend. Townsend's theory we have discussed. So same theory will be required again and again. Every units, every experiment. So I will request go through the previous videos. Try to understand that Townsend theory and then you will understand all the concepts. So again let us see that how this process is developed. Again and again I am revising. So initial first step how breakdown of this air will take place. Initial first step we have to get some electron. Free electron or dust particle should arrive in the gap. So this is the dust particle or free electron or ion. And what are the reasons we have seen cosmic rays, ultraviolet radiations or dust particle? So when this first electron or free ion or dust particle will arrive in the gap, it's not predicted. So it's statistically distributed. So this is the statistical time lag. So see, we are conducting experiment and now illumination is there in the lab. Dust particles are there in the lab. Suppose here is the dust particle. Then this dust particle will be driving towards the electrode. Here this dust particle will arrive in the gap. So some time is required because here we are giving very high electrostatic field, this field, and this field will attract due to the force, means electrostatic force of attraction. So some time, like suppose 10 second will require. On which factor will depend when dust particle will be there, or when this ultraviolet radiation will excite electron from the cathode surface, or whatever is this dust particle, when it will become charged. Statistics is there. We don't know. That depends upon statistical factors, and that is why sometimes we'll get 30 kilovolts, sometimes some variations, because we are varying voltage in the process, and that is why we have to take 5 times, 6 times readings, and then you have to find out average. So time lag you have understood, because when we apply voltage sufficient to cause the breakdown, breakdown will not take place. Breakdown will take place at a later time, and this is called as time lag. But the time required to bring this electron here, or that are some statistical. So the time lapse, which is known as statistical time lag. So what will be that? So let us see, this graph is there for time lag. Try to understand this graph. So here I am applying DC voltage, step voltage, no variations, no AC voltage. Okay, and suppose this voltage is 30 kilowatt. This voltage example we have discussed. So now you will understand this graph. So here we have just applied 30 kilowatt. Now this is my time application. I said you 10:20 am. This is time. So I will be applying and I will be waiting here. So you just see, then at this time, suppose that free electron has arrived in the graph. The first step which I told you. So here free electron will arrive in the gap, and then it will become charge. Okay, so this is statistical in nature. And here we will get that free ion, charged free ion, which will be ready to move towards the anode. And then after that again some time will be required, and we'll see this breakdown has occurred in our discussion. I told to 10:20. Suppose this is second instead of minute. Okay. So voltage collapse will occur because in breakdown voltage will be zero. Why voltage will be zero? We are applying voltage to the electrode, and here is the air which is insulating, but we are just studying the ionization breakdown. So insulating metal will get destructed, means current will start flowing, means it is dangerous short circuit. There is no resistance, significant resistance, and therefore voltage will become zero at the time of breakdown, because we cut the circuit breaker also. Okay, we cut the circuit breaker also. So here you can see when breakdown will take place due to short circuit, collapse of voltage occurs, and here breakdown takes place. So this is actually total time lag. Okay, total time lag. The electron has arrived, process has started, then electron has become charged, then primary ionization, then secondary. So let us discuss this, what is TS, what is TF, and what is T. So I told you the time lag is having two components, statistical time lag and time of formation. Okay. So after breakdown, after it appearance, electron means electron has arrived in the gap. A time TF is required for the ionization process to develop fully to cause the breakdown of the gap. Means even if now here electron has arrived, it has become charged. We have seen that has to collide with the gas molecule. Then it has to liberate electron from the gas molecule. Then positive ion has to have impact on the cathode. Then secondary electrons will liberate. This will require some time, might be fraction of second. Okay, so that is called as time of formation. So some phenomenon, some ionization process, primary ionization, secondary ionization process has to develop in the gap. So it will be fully cause the breakdown after primary ionization, secondary ionization. Avalanche is required to form. Electron will multiply. Gap will be filled up, full of gap will be full of electrons or filled up with electrons, free electrons, and then breakdown will occur. So this time is known as formative time lag. Okay, so TF is the formative time lag, and total time lag will be statistical time lag, TS plus TF, which is the total time. Okay. Now for breakdown to occur, applied voltage V should be greater than static breakdown voltage VB as shown in figure. So you just see here. This is the breakdown voltage, which is a static breakdown voltage. Means here some voltage is required to give higher than some required breakdown voltage, static breakdown voltage. Not only time is also there, but we have to apply some higher voltage than exactly the voltage required, static voltage, immediately. Because see, some voltage is required to have breakdown, but we will see that has to apply for large timers. So always some higher time is higher voltage is required. So what will be that? That is called as delta V. So you can just see this is the voltage at which breakdown occurs, and this is the voltage which is the static voltage at which breakdown can develop occur. It is just change in the voltage or higher voltage we need to apply. So the difference in voltage delta V means voltage minus VB is called over voltage, because we are giving higher voltage, we are giving voltage which is greater than static breakdown voltage, and due to that we are calling it as over voltage. And the ratio V by Vs is called the impulse ratio. So you can just see that static voltage or just breakdown voltage ratio is called as impulse ratio, that you can understand when we'll see impulse waveform also. So the variation of time of formation over delta V is shown in figure. So if you'll see variation, if delta V, what this variation indicates, so you can just see delta V, this is the time of formation and this is the percentage of delta V. Okay, suppose these are three readings. This is first, this is second, and this is third. So you can just see if this delta V is higher. This is delta V, means over voltage is less. Suppose this over voltage is less, this, because it is the percentage of. If over voltage is less, then time of formation is 60 microsecond. See, microsecond, times are in microsecond. But if you will increase over voltage, 0.5 means half percent, 50% to direct, then it will be immediately within 5 microsecond this voltage collapse, or you can just see it will occur. So time reduces. You can just see here. If the voltage, over voltage is increased, then time of formation will reduce, immediately phenomenon will develop, because it will be over voltage. This is 100% over voltage. Okay, so this is 100%, and then you can just see time of formation reduces, but you can also see some time of formation is remaining constant irrespective of, even if you are giving very higher voltage. It means that if suppose 2 microsecond is the time required for formation, you give any higher voltage, 100 or 1000 or megavolt, you cannot see that phenomenon developed within the time less than 2 microsecond, because some minimum time is required for the formation. So here there is no variation in the time of formation, because minimum time is required. And you can just see A, B, C. So it is A graph, B graph for the different gap spacing. So gap spacings are different. This is gap spacing higher. This is gap spacing higher. So if gap spacing is higher, then definitely time required will be higher. Because if gap spacing is higher, time of formation process to develop will be larger. And therefore, we have seen that when gap distance is increased, breakdown voltage goes on increasing. Okay, because process will require higher time for formation, and by that time we are continuously varying voltage. And here that this O, or you can see just like these circles are just experimental observations. So these are experimental and these are calculated points. because yesterday we have derived breakdown equation. If we know the breakdown equation, we can calculate this time of formation. We can calculate with equations, but these are experimental values which are higher, but these are calculated values. Okay, so always there will be a difference between theoretical things and experimental things. So you can just see as ore voltage will go on increasing, time of formation will go on reducing, but minimum time of formation is always required. Okay, because primary ionization is to develop, secondary ionization will be required to develop. Now what will be factors affecting? If you have understood primary ionization and secondary ionization, you can understand these factors. So factors affecting on statistical time. So this is the time required for an initiating electron to arrive in the gap, because I told you statistical time means initiating electron should get charged. This is my gap. Here is dust particle or radiations I am giving. So some time will require to have electron in the gap, initiating electron. This is the first step. So statistical time lag TES will depend upon the time required for an initiating electron to arrive in the gap. So after 1 microsecond, I have applied the voltage which is sufficient to have the breakdown or higher than that. Then after 1 microsecond, this electron has arrived in the gap. So TS will have that 1 microsecond. Also, time required to excite an initiating electron due to irradiation, cosmic rays or sun rays. I don't know how this electron has arrived in the gap. But it is also time required to excite. These radiations will excite the electron. So that is also time required. Time required to excite an initiating electron due to irradiation, cosmic rays or sun rays. Suppose this dust particle or suppose one initiating electron has come, again it will excite. This radiation will give energy to this and it will excite to move towards anode. So that time is there. Also, it is the time required for the dust particle to force in the gap and get charged. So, dust particle is causing phenomenon. So, time required to get the dust particle in the gap and gets charged, because here it is negative charge. So, dust particle will become negative charge and therefore it will get attracted towards positive plate. Okay. So, that is the statistical time lag. Now, what will be the factors affecting on the time of formation? Factors affecting on time of formation, again primary ionization and secondary ionization. So again I will explain that initiating electron has started rushing towards anode. Now it will collide with the gas molecule and it will give its kinetic energy to the valence electrons in the gas molecule, and then gas molecule will get excited, and then there will be two free electron, one from the gas molecule and one from the initial, and then these two free electrons will just travel towards anode, then again they will collide, again there will be four electrons, again there will be eight electrons, again there will be 16 electrons. So this is primary ionization. So, time required for the collision of an initiating electron with the gas molecule. Suppose this is initiating electron and it will collide with gas molecule. And then it will liberate first electron from the gas molecule. Again, this will collide. Okay, so time required to liberate electrons from the gas molecule. And what is alpha? Alpha we have considered Townsend's first ionization coefficient. And what is that? We have seen definition. We have derived yesterday last lecture. You can see that videos. So alpha is Townsend's primary ionization coefficient. What is that? It is the electron liberated from the gas molecule due to impact of a single electron. So this initiating electron is moving towards anode, and then that one electron may collide with two gas molecule. Unit journey in the direction of applied field. So when one electron will travel one unit distance in the direction of applied field, how many electrons it will be liberating from the gas molecule? Suppose it will collide with two gas molecule and it will liberate two electrons from the gas molecule. So here alpha is 2. So it will also depend upon alpha. Time of formation will also depend upon alpha. Because if alpha is 4, process will develop fast. If alpha is 1, process will develop in large time. So time of formation will depend upon time for liberating alpha, and which is Townsend's primary ionization coefficient. Now, what is happening? Now electron has rushed over the gap. Now remaining things from the gas molecule are positive ion. Okay, alpha, it will depend upon alpha, it will depend upon electrons collision time required with the free electrons with the gas molecule. Okay. But second process is that positive ion again attract towards the electrode cathode. Again they attract. Some time is required because I told you positive ions are heavier while electrons cross over the gap because they are light in weight. Moment of inertia is less here. Positive ions are heavier. So after some time, it will collide with cathode. So they will also liberate electrons from cathode. How everything we have discussed. Okay. If you miss, see that lecture. Some process will require this will impinge on cathode, then cathode electrons from atomic structure will get excited, it will become free. So this is secondary ionization. And what is gamma? We have seen gamma is Townsend's secondary ionization coefficient, which is an electron liberated by a single positive ion impact. A single one positive ion when it will impact on the cathode. How many electrons are liberated? Suppose 1, then gamma will be 1. If gamma is 2, more and more second electrons. If gamma is 3, again more means fast process. So it will depend upon gamma also. So that is the time of formation will depend upon time for liberating gamma, means time of liberating gamma electrons from the secondary, and it will depend upon gamma also. Okay. So that is about the time time lag, time of formation, statistical time lag, and the total time lag. Is there any difficulty for you students? Okay, so that time, like you have understood, now we'll just discuss important aspect from the oral point of view, Fashion's law, because we have just discussed the effect of pressure on the breakdown voltage. And just that was just preliminary introduction, how you can think, how you can apply this ionization theory, Townsend theory, primary ionization, secondary ionization. If gap distance is increased, just now we have seen if gap distance is increased, time required for breakdown will be breakdown voltage will increase, time required will be also increase. And now what will happen with the pressure? So effect of pressure on the breakdown voltage is given by the scientist Passion, and this law is also called with his name, Passion's law. Okay, so let us see what is that. So Passion's law states that, and this is very favorite question of examiner. Justify, explain, state it, apply it to discuss effect of pressure. So after learning these passions, don't say if pressure is increased, gas pressure. If pressure is increased, breakdown voltage will increase. Let us consider the before considering that law. Just I would like to tell you some effect of pressure. Again, I will like to revise it because we have discussed factor affecting on breakdown voltage. Suppose now we are applying this voltage variation in the voltage, and gas pressure is initially very low. Only two gas molecules are there. So what I can say, the electron which is traveling from the cathode towards the anode will collide with the two gas molecule, and it will liberate two electrons. That is the process. Primary ionization means there is a chance that two electrons will be liberated due to collision of this free electron with the gas molecule. Means primary ionization will liberate two free electrons. Now, if gas pressure is increased, means now there will be four gas molecules. Simple logic. If four gas molecules are there, then we can say that four electrons will be liberated. Chance is there. Four electrons will be liberated. If suppose six gas molecules are there, they can liberate six electrons. Possibility is that six electrons will be liberated from the gas molecule. Okay. And therefore positive ions will be also six. And impact of this positive ion will be also more. and secondary electrons will be also more. It means that in simple language, it means that if gas pressure is increased, breakdown voltage will increase. This is one explanation you can understand and you can explain in the oral exam. Second explanation I will give. Suppose initially there were suppose these molecules, 6 molecules or how many? 8 molecules initially. And now there is a chance of liberation of 8 electrons. Okay. From the gas molecule. Same as this. Now, suppose gas pressure is increased and now there are 16 gas molecules. Now, do you think that these free electrons will raise from 8 to 16? No. Because when free electron will start rushing towards the anode, then it will collide with the gas molecule. Then collision might be more than 8. Collision might be more than it. But free electrons may not liberate. How they see, you can just imagine. Imagine that you are standing in a one circle. And when you are standing in a one circle and with only 8 students are there and one student is rushing and this only that rushing and collision will be so dangerous. Dangerous means third means energy will be lot of transfer of energy will be given because this fellow is moving and rushing and therefore both the students will be drifted in this direction. But now when you are just rushing towards anode and just one step or two step and you are colliding with next students, what will be that collision? That will be not effective. That the students to whom you are colliding will not even drift because collisions are there but energy transfer will be less because mean free path is less, only less distance is travel without collision. It means that even not 8 electrons will be liberated because here is the crowding 16 electrons are there and now one is rushing and one free electron, just collisions are happening, no electrons because no energy gain, no kinetic energy will be higher because 1/2 mv square velocity is important, velocity will be less because where is the space to move, where is the space to move. So collision, just collision and then steady collisions means no change in the motion or movement or the placement and energy gainers. So only 6 electrons will be liberated. And if this happens means here I can say that pressure increases, breakdown voltage increases. Here I will say that pressure increases, breakdown voltage decreases. Try to understand, it's very important. And then we can say that pressure effect we cannot predict. Pressure effect we cannot predict. That depends upon which is predominant or what. If pressure is increased too much, then reverse effect. If pressure was less and then increase, the similar effect. Increase will give increase. Here increase will give decrease. If you understood, then never say today onwards that if pressure increases, breakdown voltage increases. Because usually oral happens on these aspects only. And within one question, you can finish your oral exam because as nicely you explain all the details, drawing all the figures. Yesterday also second year students just said, ma'am, let me draw and he explained. Just keeping his camera on the paper and he went writing and just saying. Okay. So we did not ask more question to him because one question indicates the depth of study, understanding, so here you be ready for this from the unit. Now let us see. Therefore, I will say that you don't say pressure increases, breakdown voltage increase. You just say the Passion's law. Okay, if question will be there, what is the effect of gap pressure on the breakdown voltage? Then say that it depends upon Passion's law and it gives effect will be described by Passion's law. And what is Passion's law? It states that breakdown voltage of a uniform field gap. Remember, this is for uniform gap. For non-uniform gap, again, the different things are happening. And for non-uniform, we have to discuss much and more detail, and we have to apply both concept, primary Townsend theory also and streamer theory also, and that becomes critical because already I told you streamer theory. You don't miss my lecture, and that will be might be Monday or Tuesday. Don't miss that lecture. And again, that applying Townsend streamer theory, will study non-uniform field, and then different interesting phenomenon happens. So remember, Passion's law is for uniform field gap. Okay, because always I'm showing you plate electron means field is uniform. So it states that breakdown voltage of a uniform field gap is a unique function of product P and gap pressure D. So breakdown voltage will be dependent on gas pressure P and gap distance D. This is very important. Product of P and D. Okay. So remember that effect of pressure means product of pressure and distance. Then voltage we have to compare. We should not compare only pressure. This here I have told you mean free path means how much distance one electron has traveled without collision. Here I am saying mean free path is more, and when collision occurs very rapidly, mean free path is less. Mean free path means it is a function of distance, of course. Here we can say mean free path was large without collision. Some distance they travel, so collision were successful. Energy transferred was lot of transfer. So excitation of electron from gas molecule is possible. Imagine this is a one gas molecule, electron is rushing, and this is just disload. This electron will disload and it will become free. But this electron is rushing, this electron is rushing and it is collide. It is collide. It is collide. No chance. Means mean free path is less. Mean free path here is more. Means distance is important. So product of pressure and gap distance is increased. Remember Passion's law. It states that breakdown voltage of a uniform field is a unique function of product P and gas pressure D. Now one important function is not there. Temperature is also important. So other conditions are remaining constant. You have to put it in bracket also. If means breakdown voltage is a function of product P and gas pressure D, other factors remaining constant. So what is Passion's law? Passion's law states that breakdown voltage of a uniform field gap is a unique function of product P. Product P means pressure of gas pressure, and distance D, gap D, distance. That is electrode gap distance for a particular gas and for a given electrode material. Okay. So that is about the Passion's law, and always Passion's law is given by this. So what is the meaning of this? Breakdown voltage versus product of pressure and gap distance. I will show you one. What is the meaning of this? So there is some minimum voltage. There is some minimum voltage. Breakdown voltage. Breakdown voltage will be minimum here. So I explain you. Initially, I explain you. Initially, if pressure is increased means product of pressure and gap distance is increased, then breakdown voltage will reduce. Now suppose this distance is maintained constant, but this variation in PD is due to increase in pressure. This graph, that is due to the increase in pressure. I have explained what happens. Initially gas molecule, two electrons will be liberated. Now this pressure is increased. Here pressure is increased. Gap distance I am considering constant, or you consider gap distance and pressure product is increased. Means what is happening here? PD is increased. Means gap distance is also increased, and gap distance is also increased. Pressure is also increased. So definitely here phenomenon will develop fast. Here 6 electrons will become free because collision will be effective. Collision will be effective. Pressure is increased. Therefore breakdown voltage reduces. So this understanding has done. Why the graph will go on reducing and you will get minimum voltage. But now if pressure becomes too crowded, here, this situation. And now you again increase that. Again increase this part. Again increase. But now here collisions are not effective. No free electrons will be liberated more. And here dominancy is that pressure mean free path is less. Collisions are not successful. Therefore, if you will go on increasing P and D more and more and more, this part breakdown voltage will go on increasing. Means after some minimum voltage, here from 2 to suppose this 4, you will get minimum voltage. This minimum voltage. But now you just try increase means crowding, and breakdown voltage will go on increasing. So this part you have understood. Inverted V. It is called as inverted V or U. Okay. Now it is similar to V inverted. Now here two graphs are shown. So for different conditions you can plot. This is for one condition. I told you other conditions remaining constant. Okay. Now here you can just see this is the product pressure. One value you can consider here, and here breakdown voltage is higher on this graph, and here breakdown voltage is less. So these conditions might be temperature, humidity, difference in temperature and humidity. And as the breakdown voltage is less here, you can see that temperature might be higher. This might be for higher temperature. This might be at less temperature or humidity, which are other factors affecting. Okay. So remember this Passion's law curve. Okay. If any difficulty is there, ask me. Now, equation form, we will just see. Okay. So it is sometimes state that write down equation of Passion's law. And here many students, when Passion's law is asked to describe, many students write down only these mathematical steps, but they forget to explain effect, how I have explained. Because you can just see no books, you will get description. Okay. No proof, no book, any explanation, whatever I'm giving you, what happens with temperature, humidity, or this gas pressure, you will not get any explanation. You have to write down that in your notebook, and you have to explain in the oral, and then you have to explain in paper also to explain the Passion's law. So when Passion's law is a statement and this explanation is important, then mathematical equation graph is important. So we have derived Townsend's breakdown criterion in presence of primary and secondary ionization. So that is this equation. We have derived condition. We discussed it three conditions in last session. Okay. So now here is the equation which we derived. So this is gamma Townsend's secondary ionization coefficient. Gamma e raised to alpha n d. This is product d minus 1. So this is exponential term which is equal to 1. So this is the basic condition for Townsend breakdown. And then we have seen these denominators to become 0, then current becomes infinite. So here what is done now, instead of alpha, value is put alpha upon pressure. Why it is put alpha upon pressure? Because this is primary ionization coefficient and this is secondary ionization coefficient. And now if we have to discuss effect of pressure, we have to bring pressure in this term. So let alpha upon P, instead of alpha upon P is a function of E by P. So what is this E? E is the intensity. This concept also you try to understand. Okay, suppose I will show you this gap. This is rod and this is plate. And suppose I am giving you, I have applied 30 kilovolt here. So if I am applying 30 kilovolt, what is the intensity at this rod and what is the intensity at this plate? So I told you intensity is equal to V by radius of curvature. Okay. Now this D is not the gap distance. It is radius of curvature perpendicular to the lines of flux. So lines of flux will be like this. We have to see this in detail in the practical. Lines of flux will be this. So these are perpendicular, means these are with, so perpendicular is distance is this. Suppose this radius or perpendicular distance is 1 centimeter. So what will be the electric field intensity at the rod? V is 30 and perpendicular distance to the lines of flux. This is lines of flux. So perpendicular distance I have to consider this. So here perpendicular distance is 1. So intensity is 30. What will be electric field intensity at the plate? This distance is suppose 4 centimeter or 3. So what will be intensity at plate? It will be voltage 30 divided by perpendicular distance is 3. So it will be 10. Here it is 13, here it is 10. And we are saying 30 kilovolt is applied. And if we consider here only plate electrode, same gap distance, same gas, everything same, then we are applying 30 kilovolt means here we are applying just you can say 30 kilovolt means what is the electric field intensity? Here 10. We are applying 10 and 10. So breakdown will happen very late here because voltage we are saying 30 but intensity is 10 and then breakdown voltage you will get 40 kilovolt suppose. And what will be breakdown voltage here? We are saying applied voltage is 30 kilovolt. But intensity is here 30 kilowatt means 30 same. So immediately breakdown here will takes place near the rod and that will develop breakdown in all the process. So for this you will get breakdown will occur at 10 kilovolt itself. This is just variation if you see. So in non-uniform field, voltage breakdown will take place very rapidly. And this phenomenon we have to study in detail. Okay. So here what I want to say, consider alpha by P is a function of electric field intensity by pressure. Because E I just explained with this. E is V by D. E is very simple to say you. V by D. In the book it is given. But what is this V by D? This is perpendicular distance. Okay. So alpha by P will be function. What will be the relationship? We don't bother that relationship. Alpha by P will depend upon E by P. That is the function. And gamma, instead of gamma, we have to put gamma is a function of E by P. And V is V by D. So put all these in our breakdown criterion. So substitute for E in the expression for gamma and alpha, you can just see here. Now here you can just see gamma is expressed as alpha upon alpha by N. Here just I will tell you electron attachment process. Okay. But I will explain you that. So this is for gamma and then e raised to alpha minus n d plus minus 1. Equation will become like this. Substituting for e. First e is substituted and then this function. First only e is substituted here and then gamma and alpha will be substituted. Okay. So that will be alpha upon alpha n will be equal to e alpha n minus d. This bracket raised to d minus 1 is equal to 1. Now substituting here for equation e for alpha and gamma, then you will get that function of now here v by d. V by d exponential and PDF. This is a PD exponential PD because alpha we are just expressing in terms of distance also pressure also. So PD function of V by PD will be equal to minus 1 is equal to this I will explain in next lecture also. I will write down myself and then will explain you in between steps. Okay. So these equations shows relationship between V and product PD and implies that breakdown voltage arises as a product of PD varies. Now this function we know that nature of functions f1 and f2 we say that voltage is equal to function of product of pressure P and distance D. This equation is known as Paschen's law. Okay. So again this Paschen's law is expressed in terms of product of pressure P and distance D. So breakdown voltage is a function of product of pressure P and distance D. These steps I will explain you. Okay again. So what is the limitations of Paschen's law? Limitations of Paschen's law, as I told, it's for uniform field. First limitation, Paschen's law is for uniform field. And at low pressure, there are deviations observed. Means again what we are saying, this Paschen's law, breakdown voltage is a function of product of pressure P and distance D is observed at a some low pressure. Okay. Some medium pressure or some value of pressure, but below that pressure, variations are observed. Means variation will not follow this graph. Okay. So very low pressure, there are deviations observed. I will tell you why. Because very low pressure means suppose only give one gas molecule. So what we are saying, one more gas molecule and two gas molecule, that will not obey this variation. Okay, because there will be number of difficulties in getting electrons, free electrons, and breakdown also. So we cannot say that as gas pressure increases, breakdown voltage will reduce. So for low pressure, there are deviations observed, and it does not hold good for composite gases, neon and argon, because here we are considering simple gas molecule, one positive and one electron, or this structure. But composite gas molecule means suppose CO2. So that will be like this. Here it will be C, and in this will be O. Covalent bonding will be there. So any composite gases like neon or argon, it will not hold good. So this whatever observations or graph we have seen, that will not be obeying for low pressure also, and for composite gases of neon and argon also. So that is the Passion's law. Now in next lecture we will see corona discharge. I would like to tell you corona discharge, uniform field, non-uniform field we'll discuss, and then we will just go towards the streamer theory. So before that you revise all these things so that you can understand breakdown in non-uniform field, corona phenomenon also, and then we'll discuss it. Okay. If any doubt is there, you can ask